Okay. All right, let's all right. All right. Okay, so this should be working now. This is the URL. Let me get that URL into Remind. New URL. All right, by the way, my PC battery is running low, so I'll do what I can till I run out. Okay. Do by new link. Okay, and you can go back with this one. Excellent. All right, good. So we can go back. So you can go back at any time for this live stream. So I'll live stream until my computer runs out of batteries and it says I have 30 minutes left. Okay. Should have brought my charger. Jeez. Okay, excellent. So please send the word out. We can go through problems now. So I'm just going to go through problems. Make sure those for you in the chat, it's your responsibility to actually mark the page number and the question number in the chat feed so people can go back to the problem. So what statement is true about the series? Let's go to this problem right now. Well, we can use the formula S is equal to A1 over 1 minus R. We know don't know what it converges to, but we know about A1, we know about 1 minus R. We know the first term, A1, is equal to the first term. And that's equal to 1. And then R is equal to what we multiply each time. So that's going to be 2/5. So R is equal to 2/5. Notice that's 1 times 2/5, 2/5, times 2/5, 4/25, times 2/5, 8 1/25. So S is equal to 1 over 1 minus 2/5. So that's equal to 1 over 3/5. So 1 divided by 3/5 is going to be 5/3. So the series converges to 5/3. It's going to be answer choice C. All right. Keep on keeping on. Once again, I'm fully responsive to YouTube comments and remind messages. But we do have 4 people watching now. I'd like to get this more interactive, so please tell your friends that this is a thing. What is recursive formula for a sequence given by 6, 12, 18, 42? So once again, there's no set pattern for addition here. And there's no set pattern for addition or multiplication. So it's not arithmetic and not geometric. Not arithmetic and not geometric. All right. So that means that we can use our recursive formula. Tn is equal to Tn minus 1 plus 2 times n plus 1. That's going to be the answer, but let's see why that is. So let's look at the first term, or the second term, 12. For the first term, 12 is 12 equal to 2 plus 2 times the previous term, 6 plus 1. That's equal to 14, so that's going to be wrong. So in this case, we're just looking at these terms, these recursive terms in what numbers are related to the previous number in the set. Is 12 equal to 6 plus 1 times 2, because it's the second term, times 2 plus 2, so is it equal to 7 times 4? Well, that's equal to 28. So that's not equal to 12. Is 12 equal to 2 times 6 plus 2 minus 2 plus 2? So that's going to be So that's going to be 2 times 6 plus 2 is 8. So that's going to be 16 minus 4 is equal to 16 minus 4. So that's equal to 12. So that's a potential correct answer. And then for D is 6 plus 2 times 2 plus 1. So that means this is going to be 6 plus 2 times 3 is 6 plus 6. That's also equal to 12. So these, both C and D, are potential correct answers. So now we just have to look at the next term. So let's evaluate C. And we continue the pattern. Is 30, which is the third term, equal to 2 times the second term, 12 plus 1, times the third term, 3 plus 2. So that means it's 30 equal to 2 times 13 plus 5. So it's 30 equal to, minus 26, 2 times 13 is 26, so 26 minus 5, which is equal to 21. Well, 30 is not equal to 21, so we can eliminate answer choice C, and that leaves us with D. So this one's a little bit more tedious, but if you know what you're doing, you can solve it. Okay, 4 people watching. Let's, I really want more people to turn out to this. Let's just keep going with recursive then. All right. How many terms of the sequence 1, 3, 3 halves, 3 cubes must be added to get 3,280? At this point, in the interest of time, because there's 4 people, I'm just going to get from the YouTube video. I'll just show you the results. Let's wait till that. Okay. This shows you everything. How many terms of the sequence must be added together to get 3,280? Well, we know an is equal to a1 times r to the n minus 1. So an is equal to 1, the first term of the sequence, times 3 each time you multiply by 3 to the n minus 1. So an is equal to 3 to the n minus 1. So that's applying it, but we really need to find the series. So we need to find Sn. Sn is equal to a1 times 1 minus r to the n over 1 minus r. 3,280 is equal to 1 minus 3 to n over 1 minus 3. That's equal to 1 minus 3 to the n over negative 2. We multiply each side by negative 2. So 6,560 is equal to 1 minus 3 to the n. Subtract 1 from each side. Negative 6,561 is equal to negative 3 to the n. 6,561 is equal to 3 to the n, which is equal to the log base 3 of 6,561 of n. And so that's going to be equal to n, which is going to be equal to 8. So those are the steps. And because you can rewrite now, you can always go back to it. So let's wait for the stream to catch up. All right. The first term of an infinite geometric sequence is 2. The sum of the sequence is 6. What is the common ratio of the sequence? So the formula for a geometric series, S is equal to A1 over 1 minus R. So 6 is equal to 2 over 1 minus R. So 6 times 1 minus r is equal to 2. 6 minus 6r is equal to 2. Negative 6r is equal to negative 4. R is equal to negative 4 over negative 6. R is equal to 2/3. And so that's the ratio here. And that's the answer. Okay, let's go to number 15 or number 8. An is equal to a1 plus n minus 1 times d. So Sn is equal to n over 2 times a1 plus an. So these are the arithmetic formulas. Then you have 975 is equal to 15 over 2 times 16 plus an. 975 over 7.5 is equal to 16 plus an. 130. So notice I just divided each side by 7.5. We divided this by 7.5. So 130 is equal to 16 plus an. Subtract 16 from each side. 114 is equal to a the 15th term, A15. So with that being said, we have A20 is equal to 16 plus 19 times 7, which is 149. So that's the 20th term. But the sum of the 20th term is going to be 20 over 2 times 16, the first term, plus 149, which is equal to 1650. So we had to find out what the 20th term is. A20 is equal to 16 plus 19 times 7. So 19 is the 20th term minus 1. 7 is D. And then we calculate S20 based on that 149 value that's right there. So that's number 8. Please, once again, please remind me questions. Please ask me questions. I can respond to feedback only if you give it to me. All right. Which statement is true about the series shown below? I'm going to say it converges to 4 pi. Let's find out why. So notice the first term we have pi over 1. Then it's 3 pi over 4. So that means we multiply by 3/4, which is equal to 3 pi over 4. Then we multiply by 3/4, which is equal to 9 pi over 16. So R is equal to 3/4. And we know that the series is equal to A1 over 1 minus R. So that means the series is equal to our first term, pi over 1 minus 3/4. So that's equal to pi over 1/4. And pi divided by 1/4 is equal to 4 pi. Answer choice D. Karen recursively generated a sequence of 5 positive integers by starting at a positive integer, a1, and then applying the recursive formula an equals an minus 1 plus 3n minus 1 to generate an for 2, 3, 4, and 5. If the value of a5 was 407, what was the value of Karen's starting term, a1? Well, what we can do is we can work backwards from the 5th term. So A5 is equal to 407. But that means that A5, we can also say that 407 is equal to A4 plus 3 times A5 is the 5th term, so that means n equals 5. 3 times 5 minus 1. So that means that 407 is equal to A4 plus 15 minus 1 is going to be 14. And so A4 is going to be 407 minus 14. So you subtract 14 from each side, and you'll find that 407 minus 14 is 393. 393 is equal to A4. Let's try A3 now. So to evaluate A3, you can say 393 is equal to A3 plus 3 times n minus 1. 3n minus 1. So that's going to be, this is A4, so this is the 4th term. So 3 times 4 minus 1, 12 minus 1 is 11. So that means A3 is equal to 393 minus 11. So 393 minus 11 is 382. So A3 is equal to 382, which means that 382 is equal to A2 plus 3 times 3 minus 1, which is going to be 382 equals A2 plus 8. So 382 minus 8 is 374. So 374 is equal to A1 plus 3 times, this is the second term, 2 minus 1. So that means 374 is equal to 3 times 2 is 6 minus 1 is 5. So 374 is equal to A1 plus 5. So subtract 5 from each one, that's going to be 369. So A1 plus 5 is equal to, so subtract 5 from each side, you have A1 is equal to 369. And the answer is D, 369. So once again, you're not explicitly adding or subtracting or multiplying by a specific term each time, so you just have to work the sequence out backwards to forwards. And you have 3.5 minutes per question, so this process probably takes you about 3.5 minutes to work it out and actually get it, but that's okay. Take the time that you need to quickly look at a function problem, know how to solve it, and then do it. A sequence of numbers is defined as A1 equals 7, A2 equals the cube root of A1 plus 1, and A3 is equal to the cube root of A2 plus 1, and so on. What is the value of A5 to the nearest hundredth? So what we can do is A1 is equal to 7. A2 is equal to the cube root of 7 plus 1. A3 is equal to the cube root of 7 plus 1 plus 1, and this just becomes more and more embedded. So, but because this gets complicated, we'll evaluate it each time. So we find, math for the cube root of 7 plus 1. Then we take math for the cube root of that value plus 1. So that's we'll keep track of our terms. So A1, 7, A2 is equal to 2.91, A3 is equal to 2.42, A4 is going to be the cube root of this value plus 1. So A4 is equal to 2.344, and A5 is going to be math cube root of that value plus 1. That's going to be equal to A5 is equal to 2.328. And by the way, the answer choices in your packet are going to be wrong, but the answer will be 2.33. If you corrected your packet using the packets file I posted, you should be good to go. All right, still for watching. Wow, I'm just the most popular bell at the ball. All right. How much battery do I have left? 15 minutes left. Mr. Smith has recently retired, and he will rely on the savings to supplement Social Security. His account with the balance of $25,000 in 2018 when he retired. The account earns interest at a rate of 4.8% annual interest, and the interest is compounded annually. Mr. Smith will withdraw $9,000 from the account each year, which correctly gives a recursive formula to represent the situation. So let's look at the each term is equal to a 4.8% increase of the previous value, and then you subtract 9,000. So, first of all, because he's withdrawing 9,000 each year, that means you take away. So that means you can eliminate B and D. Because you're adding. So you can eliminate B, you can eliminate D. So let me adjust the paper for y'all. Oh wow, 2 people are watching. We're so popular. And now we look at what the interest rate is. Is it 4.8% or 95.2%? The interest rate is 4.8%, so that's going to leave us with the answer choice A. All right. 3 people watching now. Oh, and 2 of those people watching are my screen. So we got 1 actual person watching. Nice. Hello there. There are 15 rows of seats in the concert hall, with 25 seats in the first row, and 27 seats in the second row, 9 seats in the third row, and so on. If the concert hall sells out and charges $12 per ticket, how much money will they have made? The answer is going to be $720, but let's see how we get there. So each time we increase in 3 seats, so we can use, let's use our formulas for arithmetic and geometric sequences, because this is an arithmetic sequence. All right. So Sn is equal to n over 2 times a1 plus an. Let me double check that again. And you'll have this on your formula sheet, so first of all, we need to find